Hello and welcome to today's video. In today's video, I'm going to develop a 3D game such as Call of Duty with you guys and see how we can write a program like this. Of course, I'm kidding. We're not going to do that. We're just going to go over 4 practice problems like what we did last week. Okay, similar to last week, the link to the each part of the video that I'm talking about different practice problems would be available on the description below. So feel free if you wanted to jump between the practice problems, go ahead and use that link. The first problem is to write a program which reads a car license plate and prints the result to the screen. Your program input and output should look like what you can see in the screen. Enter the license plate number, 3 letters and 3 digits. For example, you enter MYT549, and then your program outputs, you entered MYT549. A sample problem has also been provided to us, as you can see on the screen. I copied the code to my editor, in this case Visual Studio, and as you can see, the code is for writing a program that reads and writes license plates. Okay, the first thing I wanted to do, I wanted to divide it into different tasks so I know what tasks to tackle to complete this program. So step 1 in this case is to declare my variables. Step 2 is to ask the user to enter the license plate. Step 3 is to scan the license plate. Step 4 is to print the entered license plate on the screen. In this question, I'm going to talk about step number 3 for you guys. We are going to scan what the user will input. So for the first argument in the scanf function, I have to provide the format arguments, the format specifier for how I wanted to read this license plate. You can go ahead and have 2 different ways to do this. You can, because license plates in Canada are 3 letters and 3 numbers, you can go ahead and read all of them using characters, so 6 characters. Or you can go ahead and read 3 characters for the first 3 characters, for the first 3 letters of the license plate, and then go ahead and read all the numbers as an integer number. For example, if it's 321, 321 is 321, it's an integer. You can read it by only 1% d. So it could be either %c, %c, %c for the first 3 characters, and then %d to read the integer number, or all 6 of them could be 6 different %c. And then in the argument, so it would be different as well. Let me actually have both scenarios for you here. So it depends on how you create your variables, but let's imagine that I have character C1, character C2, character C3, character C4, and until C6. And in the case that I'm reading it using integer, I will have 3 characters, C1, C2, and C3, and 1 integer, let's call it D1. So this is the 2 alternative ways that you can read this license plate. By now, I know you can declare your variables, prompt the user to enter the license plate, and print the license plate that you already read from the user on the screen. But if you have any question, don't hesitate to ask. Okay, let's jump to the second problem. The point is, when floating point number, float data type in C, are added in C, round-off errors can occur if the number differs by more than 7 significant digits. To illustrate this round-off problem, the question is asking us to write a program to use the quadratic formula to solve ax to the power of 2 plus bx plus c equals to 0. For real in values of a, b, and c, this program must use the data type float throughout this program. Your program should input and output look like what you can see on the screen. So for example, enter the 3 digits of 1, -5, and 6. So A is 1, B is -5, C is 6, And as you can see, root 1 is 3 and root 2 is 2. So we're basically getting a quadratic formula. We store the values using float numbers, and we calculate the roots, and we output the roots. As you can see, the program is asking us to try to consider two different cases for this problem. One is 1 minus 5 and 6, and the other one is A is 1, B is negative 10.0001, and C is 25.00015. So in case 1, we should get the roots to be 2 and 3, as on the expected input and output it was also the same thing. But in case 2, there will be the precision problem, and the estimate roots will be near but not equal to the actual value. The actual values would be 5 and 5.0001. So recall that quadratic formulas can compute the 3 coefficient. The mass equations you need are as follows. So you see that delta, which we will show it by d here, is equal to square root of b squared minus 4 times a times c. And then root 1 will be calculated as minus b plus d divided by 2 times a. And the same thing for the root number 2, but this time minus b minus d divided by 2a. So the sample code provided for this question is also available on the screen. I've copied the sample code provided in the question into my editor, and now the first thing I'm going to divide them between different tasks to know which task to tackle. But one thing that I wanted to talk to you guys here is at line number 5, I have include mass.h. So we are including mass library. Mass library is a great tool in C programming that you can access to mass equations like sqrt for calculating the square root of a number, or FABS for calculating the absolute value of a number. These are a handy tool that we are going to use in this video. Okay, so let's get back to the work. Step 1, again, as always, is to declare your variables. Step 2 is to prompt the user to enter the 3 coefficient. Step 3 is to scan the 3 coefficients. Step 4 is to calculate the roots. Step 5 is to print the output on the screen. So as the question is asking, we are defining our variable using the keyword float. So float is the single precision float numbers, and I'm going to create 3 float numbers for A, B, and C. And these 3 are the 3 coefficients that I want the user to enter. I need more variables, and I need a variable to hold root number 1 and another one to hold root number 2. And I need another variable, and I will call it d, and d is going to store delta. That the equation for delta is being provided to us. It's the square root of b times b minus 4 times a times c. Okay, so the first task is to prompt the user to enter the coefficients. So printf function is the choice here, and inside the quotations, I'm going to say the message, enter the 3 coefficients. And the next job is, we forgot the semicolon. And the next job is to scan what user has entered. And I'm going to use a scanf function. And for the format specifier, I'm going to use 3%f, but there has to be a space between them. So make sure that user is entering 3 different float numbers as the first argument in the scanf function. And as the second argument, I want to tell the C compiler where you should store these numbers that user is going to enter. And the first is going to be entered on the variable A. Second %f will be stored under the variable B, and the same thing for the third one. Will be stored on the address of the variable C. Okay, now is a good time to put a breaking point at line 16 and try to debug my code to see if everything is working or not. So I'll go to debug menu and I'll click on start debugging. Okay, so in the debug window, if I step over of the scanf function and enter, as you can see on the window, so I will enter 1, 2, and 3. And if I press enter, on the local window, as you can see down here, the value of A, B, and C is changed to 1, 2, and 3. So I know that my code is working up to this point. I can close the debugging window by just pressing this stop button and then continue my writing step 4. Step 4 here is I need to calculate delta, and using delta I can calculate root 1 and root 2. So D is equal to, and as we said, it's not equal sign, it's assignment operator. And for the right hand side, I wanted to calculate the square root of b to the power of 2, b times b, then minus 4 times a times c. So this will calculate the delta for me. And now using delta, it can calculate root 1. The formula for root 1 as provided in the question is minus b plus d divided by 2 times a. So you see that whenever I'm using a value, a number, I'm putting 0.0. You might say it's 4 or it's 2. Why would you put 0.0? You can only say 4 or 2. Correct, but the point is, if I put 2 or 4, C would think that this number is actually an integer. But because all my variables here are float numbers, I want C to consider it as float numbers. Even now, it's not a float number. 4 and 2 are doubles. So if you just put a number with decimal points, C would consider them as float numbers. If you doubles. And if you want C to consider them as float numbers, just add a keyword F to the end of them. So this program that we are writing, we want everything to be float. So I would add the character F after 4.0 and 2.0 to make them float numbers. Okay, so the same thing, we're using the same scenario. I can calculate root 2, and root 2 is equal to minus b this time minus d, and then the rest is the same. 2f times a and semicolon. So now I'm going to move my breaking point, or remove the breaking point on line 16, put one on line 19, and start to debug the code again. I'll press F5 to go to the debug window, and I'll input 1, -5, and 6. If I press enter, we'll go to the debug menu and the local window will open. I know that A and B and C, now it's correctly being read because we just checked it on the step number 3. It's 1, -5, and 6. And let's see if our delta D is calculated correctly. The only way to check it is to see if root 1 and root 2 are being calculated the way we want it or not. So if the instruction pointer is pointing to this line, it means that delta has not been calculated yet. If I step over, you would see that the value of D changes. This negative value, it means that the variable D has not been initialized yet. And the same thing happened for root 1 and root 2. Root 1 and root 2 have not been initialized yet. And if I step over line 21, root 1 will be calculated. And if I step over line 22, root 2 will be calculated, and it's 2 and 3, which we expect it to be, and it means that the code is working correct. Now we can go and tackle the last task, which is printing the output on the screen. Okay, so what I'm going to do, I'm going to just bring the output that the question is asking as comment here after my code. I just wanted to have it here so I know how to write my printf functions. Here, I'm going to have a printf and then the message inside the printf. So the first line is, we actually did it. It's the input one. We want to say a is equal to, and then as you can see, the value of a is being printed. So I'm going to put a formatted specifier %f for the float number, and as I wanted to put the value of the variable a instead of %f, so that's done. And then I'm going to have the same printf function for b and c, and then I'm going to print the value of root 1 and root 2, the same way that I printed the value of a, b, and c. And that concludes the printf functions that I wanted to have for step number 5. So let's Control F5, this time compile our code without debugging to see if our code is working or not. For the first of inputs, I'll put 1, -5, and 6. If I press enter, okay. The problem is everything is back to each other and it doesn't look like the way it was printed on the output. And again, the reason is we didn't put \n. So if I put \n at each printf statement, so be careful that if you don't put \n, it won't go to next line. Okay, so now again, I'm going to press Ctrl F5 and then enter 1, -5, and 6 and press enter. Okay, now the output looks like the same output provided in the question. It says A is 1, B is -5, and C is 6, and root 1 is 3, root 2 is 2, as we expect it to be. Okay, I'll close this window and I go back to our code. We wanted to try our code with another set of examples as well. I'm going to press Ctrl F5 again to compile and run the code. And this time I'm going to enter 1, -10.0001 and 25.0005. And if I press enter, the output is A is 1, B is 10.0001, C is 25.005, and root 1 is 5.00141, and root 2 is 4.998669. Clearly, the last two roots are not calculated correctly. I would say the accuracy is not enough. The accuracy of the variables were not enough to allow us to see the correct values of root 1 and root 2. As you saw, the roots we calculated for the second set of the input was not correct. That leads us to the practice problem number 4. This practice problem is asking us to modify our code and use double data type instead of float to see if we can increase the accuracy of our code. You should be able to do that on your own. You just need to change the data type from float to double, but you have to note something. Whenever you're using %f for the format specifier for float, you better change it to %lf because %lf is format specifier for doubles. And whenever you have an actual number in a float equation, you would put a character f at the end of it to tell C that this is actually a float number, but you don't need that character f anymore. In practice problem number 4, we will practice more functions in math library. The question is telling us that an approximate value of square root of 1 plus x is the formula you can see on the screen. This formula will give a reasonable assumption provided that absolute value of x is less than 1. The approximation improves as the absolute value of x gets smaller and smaller, and we can test that with our program. Write a program to test the accuracy of this formula for various values of x. Your program should compute the above relative error. So the formula for calculating relative error is also provided us by the question, and we can use it to see the percentage of the error. Our input and output should look like what you can see now on the screen. So your program should input, like enter x, column 0.5, and then it will say what was x. X was 0.5, and that approximate value that is calculated using the formulation that is provided. and the actual value just by using a square root of 1 plus x, and then the percent relative error, which we also provided by the formula, which is just put the numbers in the formula. And then we have also been provided by a sample code in the question, as you can see on the screen. We just need to copy that to our text editor and start writing the code. Okay, so I have copied the sample code provided to us by the practice problem to my text editor, in this case Visual Studio. And as always, I'm going to break it into different steps and try to tackle the steps one by one. And as always, step 1 is to declare all the variables, and step 2 is to ask the user to enter x and scan x. Step 3 is to calculate the square root of 1 plus x, but using the approximate formulation. And step 3 is to calculate the square root of 1 plus x, but this time the actual value. Next step is to calculate the relative error. And the final step is to print the output on the screen. Okay, so the variables I need for this code are, I need x, the variable that the user enters, because we wanted to calculate the square root of 1 plus x. I need the variable float number to store the approximate value, and I call it approx. I need another one to store the actual value. I call it actual. And I need a variable to store the relative error, which I'm going to call it relative error. Okay. On step 2, I'm going to ask the user to enter a float number, and then I'll read that float number using scanf function. So in this step, you're going to use printf function and scanf function. And to calculate the approx, the variable we just introduced, or the approximate value, I'm just going to use the variable name and then assign an operator. And if you look at the formula, it's 1 plus, and because everything is float, I'm going to add this character f at the end of the numbers that I'm going to put here. And for the second term is 1 divided by 2 multiplied by x, and the next term, and I will continue to have all the terms here. And step 4 would be to calculate the actual value, and the actual value is actually, we're going to use a function in the math library, which is the square root function, and I'm just going to calculate 1 plus square root of 1 plus x. So that will tell us what is the actual value. Let me put a semicolon here so it won't indent my code. Okay. And step 5 is to calculate the relative error. And to calculate the relative error, you need to use the, let me actually write it, relative error assignment operator, and then absolute value of the approximate minus actual divided by actual. So to calculate the absolute value, I'm going to use fabs function, which will calculate the absolute value of any number you in between the parentheses. So here you're going to put approximate minus actual divided by actual, and then the whole thing will be multiplied by 100 because we wanted to see what is the percentage of the error. And in order to print the result on the screen, you need printf statements. You want, based on what you've been asked by the question, you wanted to say what is x, and what is the approximate value, what is the actual value, and what is the percentage of the relative error. The question is asking us to test it with two different values, 0.5 and 0.99, to see how the error changes. And you would see that the error is smaller for smaller values of x. You can do the rest of the problem, and if you have any error, you can. One thing that you should note in your program is the division. So whenever, for example, you have 5 divided by 128, if you say just 5 divided by 128, as you can see on the screen, the result would be 0. Because C would think that, okay, you're dividing an integer by an integer. There's a high chance that you need the return value to be also an integer. And then if we divide 5 as integer by 128 and ask for an integer, only integer part of that division, it will return 0 for us. But if you wanted to get the decimal points, you better tell C that to use double or use float. So what I would do here, if it's float, I would say 5.0 and a character F divided 128.0 character F. And if it's double, I would just say 5.0 divided by 128.0. Thank you guys for watching, and that concludes the next video regarding practice problems set number 2. If you have any question, don't hesitate to ask. We are here to help you. Have a good day and see you guys in the next video.